Hey everyone, welcome back to Mind Maths with Amina. Today I'm going to solve another question given the study guide from chapter 2 named Data Visualization and Descriptive Statistics. It's under the heading Test Your Knowledge, Test Your Understanding actually. The question goes as follows. At a time of economic growth but political uncertainty, a random sample of 40 economists produces the following forecasts for the growth rate of an economy in the next year. So 1.3, 3.8. As you can see, unfortunately, this data set is not ordered. The first thing, before even reading out the question, I can see they're asking for a histogram, they're asking for a stem and leaf. So the first thing I would suggest is to order the data set, and the best way of doing that is actually drawing the stem and leaf diagram first. So this is my number one tip, that even if the question hasn't asked you directly for the stem and leaf diagram, please do still make it if especially the data set isn't ordered. I'll just write this down as a tip, that if the data set is unordered, then even if the question doesn't require you, still draw a stem and leaf, because that will help you make the to find the mean, median, mode, and all the other things that they usually ask. Okay, so let's start. We have a 1 point something, right? So the stem can show the percent value. So, and the leaf, or I can just actually write the stem is the number in this is the growth rate, so it has to be in percent. So yeah, so let me, if 1.3 means 1%, right? So in percent, I was writing it correctly, percent. And the leaf is what follows after that, so the digit afterwards. So let's see what is with 1. Okay, a 1.3, and the next column we don't have any. Okay, we have 1.9, 1.9, 1.8. So I think this is it, and I need to write it in the ordered way. So I'm going to write it 3, 8, 9, 9. Okay, so 3, 8, 9, 9, and we have basically 4 entries here. Okay, with 2. Let's first highlight whatever I have with 2. The first column has nothing, the second column has just 1 entry, the third has nothing, fourth has these 2, fifth has this one, sixth, and the 7th column, the 8th has nothing, 9th, okay, the 10th has this. Okay, again I need to write them in ordered way. I can see we have a 3, 6, 5, 4, 2, 5, 2, 7, 8. So I first of all, I just write it without putting order in it, and now I'm going to write it in order. 2, 2, 3, then we have a 4 actually, then 5, 5, 6, 7, 8. Okay, and how many entries is that? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 entries here. Okay, now going on to 3. And the first column has 3.1, then 3.8, 3.1, 3.3, 3.7, 3.4, 1, 9, 4, 3, 4, 3, 6. That's it. Okay, so first I'm just going to write it column by column. We had a 3.1, then 3.8, 3.1, 3.3, then 3.7, then a 3.4, 3.1, 3.9, 3.4, 3.3, 3.4, 3.6, 3.3. Okay, now that I've done this, I want to put it in order from the lowest to highest. So I have 3 ones. Okay, 1, 1, 1. Okay, and then we have 3, 3, 3. Then we have 3 4s. Okay, that's kind of funny. 3 4s. Then we have a 6, 7, 8, 9. Nice pattern. How many entries? Oops, that was the eraser. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, 13. Okay, what with 5, 6, 7, 8? Okay, with 4 in the first column, we have a 4.3, 4.1, 4.2, 4.5, 4.6, 4.1, 4.7, and 4.4. Let's just write it without order first. 4.3, 1, 2, 5, 6, 1, 7, and 4. Now that I've done this, I want to write all of this in order. So we have a 1 and a 1. Then we have a 2. Then we have a 3. We have a 4. We have a 5. We have a 6. We have a 7. Okay, good. How many data points is this? 1, 2, 3, 4, 5, 6, 7, 8. 8. Oops, I took out the pencil. 8. Okay, with 5. Okay, we have a 5.4. Let me use another color as the highlighter. We have a 5.4, 5.2, 5.1, 5.2. So a 1, 2, 2, 4. 1, 1, 2, 2, 4. We have nothing with the, did I forget a 2.9? Oh, see, this is why this was beneficial. I forgot a 2.9. So this should be in green and 2.9 should come here. So we have 10 entries here. Okay. With 6, there's nothing. And with 7, there's just an 8.2 over here. 8.2. So that means nothing with, I can't add a 0 here. Nothing. That if I added a 0, it would have meant a 6.0%. I don't want that. That would have been an entry. There's actually no entry here. There's no entry here. And we have a 8.2 here. Just a 1 entry. This was 4. As you can see, the data set is positively skewed. So we would expect that if the data is positively skewed, then the mean would be greater than the median, and the median would be greater than the mode. So we've effectively solved part B of the question. So let's draw. And I've already also commented on the shape of the distribution. It is, you can see it is positively skewed, and we do see an outlier here. You can even mention it's positively skewed because of this outlier value. Okay, let's do part A. They want us to draw a density histogram. Okay, I've already actually done this before. Okay, for this part, remember, it's because we already have the data set in a stem leaf. It's going to be very easy for us to write it in ordered form. So let's write it in ordered form. 1.3, 1.8, 1.9, 1.9. Then we have a 2.2, 2.2, 2.3, 2.4, 2.5, 2.5, 2.6, 2.7, 2.8, 2.9. Yeah. Then a 3.1, 3.1, 3.1, 3.1, 3.1, 3.1, then a 3.3, 3.3, 3.3, then a 3.4, 3.4, 3.4, then a 3.6, 3.7, 3.8, 3.9. Okay, moving on. 4.1, 4.1, 4.2. This is quite exhausting. 4.3, 4.4, 4.5, 4.6, 4.7. Then we have a 5.1, 5.2, 5.2, and a 5.4. And then lastly, an 8.2. So let's just move this here so that I can have everything in the one page. As you can see, I am a neat freak when it comes to notes, because if I make things messy, it's very hard actually for me to understand what I did. So I need to make sure that everything is legible. Okay, so this is the data set which is now ordered, and I want to draw a density histogram. Okay, so first I want to establish the range approximately. What I can do is I can start from a 1 and then I can end with a 9, right? So the highest value I can approximate as 9 and the lowest I can approximate as 1. Even though the lowest value is actually a 1.3 and the highest value is a 8.2, but I want an approximate range, so the 8 is the range is enough. Okay, what do? We can actually now decide what should be the width of my class interval and how many class intervals should I get. One tip is to basically, since our sample is 40, one trick is to take the under root of 40, and that gives you a very a good approximate number of class intervals that you should keep. So under root of 40, my calculator says it's a 3.62. So we can take this as a 7. Actually 7 would be difficult. Let's just take an 8 then. So the reason being because 8 divided by 8 gives me a very nice 1. So the width of each can be the range over the number of intervals. So this is the number of intervals that we've decided. So the width should be a 1. Okay, so let's start. The class interval, remember the lower value is included and the upper is not. So we have from 2 till 3, from 3 till 4, from 4 till a 5, from a 5 till a 6, from a 6 to a 7, from a 7 to an 8, from an 8 to a 9. Okay, these are the class intervals, and I've actually decided one width for all of these, which is 1, 1, 1, 1, 1, 1, 1, 1. Okay, this frequency is, we have 4 entries here. So 4, 10, 13, 8, 4, 10, 13, 8, and then we have a 4, 0, 0, 1. 4, as you can see, the stem leaf actually helps us draw the histogram as well. So even if the examiner places this in the first part and the stem and leaf in the second part, I would always suggest to make the stem and leaf first. It makes the histogram process much easier. Okay, after the frequency, we wanted the relative frequency, which is frequency divided by the number of data points. So we have a 4 divided by 40, which gives us a 0.1. Then a 10 divided by a 40, which is a 0.25, and so on. You do a 13 divided by 40, you'll get a 0.325, and 8 divided by 40 is a 0.2, a 4 divided by 40 is a 0.1, 0 divided by 40 0 0, 1 divided by 40 0.025. So this is the relative frequency. And finally, the density is the relative frequency divided by the class width. Since the class width is a 1, so the relative frequency and the density is actually the same. So all these values are the same. Now we have all the information that we need to draw the histogram. And what we're going to do is that I'm just going to make a wiggly kind of sign here to show that this starts from 0 and comes to the value that I want. The class, okay, mine starts from 1, 2, 3, 4, 5, 6, 7, and then we have an 8. Let me shift this forward. Oh, this is so frustrating. I'll just extend it like this. Okay, 8. So these are the bins, or basically the intervals. And the density of each is, as you can see, the values are quite small. So what I can do is I can start with a 0.25. So we can do it like this. Just keep a 2 gap. So this is a 0.25. Oh, was it another 0? Yeah, sorry. 0.25. Then we'll get a 0.050. Then a 0.075. Then a 0.01, I think. And then a 0. Let me just take out my calculator because I don't want to make a mistake. Let's start over. Plus 0.25, 0.25. Yeah, I was right so far. Oh, I'll get a 1 here. Okay, plus 0.25, 125. Okay, then 0.15, then a 0.2. I think this is enough. Okay, for the first interval we have a 0.1. Okay, so the first interval we have a 0.1. Wait, let me just make the vertical lines first. We have a 0.1. Okay, for the next we have a 0.25. Oh, that's going to be above. So I'm just going to like take an estimate. This is definitely not being drawn to scale. So okay, it's from 3 to 4. It is a 0.325. Oh, I don't even have that on my scale right now. Sorry guys, I'm just going to approximate this. So it's going to be somewhere over here. You get the picture. Why is this not cooperating today? Okay, from 4 to 5 I have 0.2. 0.2. Okay, and then from 5 to 6 as 0.1. Then there was nothing over here, and then from 8 to 9 we had a 0.25 like this. So this is what the histogram will look like, but I haven't really drawn it to scale, that's why it looks kind of weird. But even from this rough sketch, you can tell that the data is positively skewed. So because I can make a line like this that goes, you can see the tail goes towards the right. Okay, so we've done part A. And B and C. Determine the median of the data set using the stem and leaf in A. Okay, so they want us to use this, and they want us to determine the median. Okay, so there were 40 entries, right? So since n is equals to 40, then n plus 1 over 2 is going to be a 41 divided by 2. So we have a 20.5. So the median is going to be the average of the 20th and the 21st observation. So till here we have 14 observations. So that means this is going to be the 15th, 16th, 17th, 18th, 19th, 20th. So that means our 20th observation is a 3.3 and the 24th is going to be a 3.4. So we have a 3.3 plus a 3.4 divided by a 2. Why did I write 5? I don't know. Okay, so the average is going to be a 3.35. So that's the median. What does the next question ask? They want us to produce a box plot next. Remember, the box plot requires us to find the interquartile range. So for part E, I need to find the upper quartile. So 75% of the observations lie below it. So we multiply, actually this is just the observations. 75 of the percent, which is 3 by 4 multiplied by a 40. So that's a 30th. The 30th observation. So Q3 is simply the 30th observation. So let's use the stem and leaf. If I do a 4 plus a 10, I get a 14. If I add a 13, that's a 27. So all the terms still here are 27. I needed the 30th. So 28, 29, 30. So that gives us a 4.2. That's my upper quartile. What about the lower quartile? 25% of all observations lie below it. So now I'm interested in 1/4 of 40, and that gives me the 10th observation. So we have 4 observations still here. So this is my 5th, 6th, 7th, 8th, 9th, 10th. So my 10th observation is a 2.5. So that is my lower quartile. So what about the interquartile range? The interquartile range is simply a 4.2 minus a 2.5, and therefore that is a 1.7. Remember, we needed to make a calculation. We want to see what is the maximum between the lowest value in the data set and Q1 minus 1.5 multiplied by the interquartile range. The lowest value in our data set was, I believe, a 1.3, and Q1 is a 2.5 minus a 1.5 multiplied by 1.7. So this becomes we can use our calculator, and this becomes a minus 0.05. Okay, the minimum is the maximum is a 1.3. So that means that we don't have any outliers when it comes to the lowest values. Okay, now the upper values, the minimum of the highest observed value, or Q3 plus a 1.5 into the interquartile range. Okay, the minimum, what was the highest value? It was a 8.2, and the Q3 was a 4.2 plus a 1.5 into a 1.7. Okay, so when we use a calculator, we'll have 8.2 and a 6.75. So the minimum is a 6.75. That actually tells us that the value 8.2 is just an outlier, which means that since the outlier is towards a higher value, then it's basically outside this, outside our dot plot. Therefore, our distribution is going to be positively skewed. So let's make a rough diagram. Okay. We have a 6.75 here. We have a 1.3 here. Why isn't this here a vertical line? Okay, a 1.3 here. Then we have a 2.5 here and a 4.2, the upper quartile. And now we need the median, which is a 3.35. It's closer to the upper quartile. So over here, 3.35, and there's one outlier over here, which was a 8.2. It lies outside the dot block, so that's why it's the outlier. Okay, we've done part E. Using the following summary statistics, calculate the sample mean. Okay, this is easy enough. The sum of all the entries is a 140.4, and the sum of the squares is a 557.26. For such a question, all you need to know, actually you'll get the formula sheet, but if you've practiced enough, you would have these formulas in your brain by heart. Okay, so the mean is just the sample mean. Actually is I'll actually denote it by x bar. It is the sum of all the observations divided by the total entries, which in this case was a 40. So a 1404 over a 40, which gives us a 3.51. Okay, the sample variance is a 1 over n minus 1. This is we don't divide it by n because we need a unbiased estimator. So therefore, when we divide it by n minus 1, that is when we get an unbiased estimator. Okay, so we have a 1 over a 39, and the sum of square was a 557.26 minus n was a 40, and the average is a 3.51 square. When we use a calculator, the answer is a 1.627. So the standard deviation is simply the under root of the variance, and when we take the under root, we get a 1.29. Okay, so the mean we can see here is a 3.59, whereas the median that we calculated previously was 3.35. as expected, the mean is greater than the median because we have a positively skewed data set. Okay, we are done with part F. Now moving on to part G, comment on the relative values of, I've already commented that whenever a mean is greater than the median, then we have a positively skewed data set. Okay, what percentage of the data fall within one sample standard deviation of the sample mean? Oh, that's interesting. Okay, so x bar minus 1 into s, and within, like, I'm interested in what values lie between this. Okay, so the answer should be x bar plus 1s. Okay, and what percentage fall between two samples? Okay, then the next thing it's asking us for what values, what percentage fall between two sample standard deviations of the sample mean. Okay, then we have to multiply 2 by s. So let's see how many entries fall within this range. What we can expect is let me first do a rough diagram. This was, I believe, part H. What we expect is that, let me just make a normal distribution centered around. So if this was the mean, then x bar plus 1 standard deviation away would be like this, and this is the percentage, the area shaded is the percentage of entries that are within 1 standard deviation. Okay, and then what about x bar plus 2 standard deviation away from the mean? As you can see, the shaded area in this, why did I say plus? It's actually a minus. I'm always in such a hurry that I make such stupid mistakes. Minus. Okay, so as you can see, the area now expands. So what I'm expecting is that the percentage of entries within 2 standard deviations away from the mean will exceed, right, the number of or the percentage of values between 1 standard deviation. So let's make this calculation. So x bar minus s is a 3.51 minus a 1.29, which is a 2.22, and x bar plus s is a 3.51 plus a 1.29, which is a 4.8. Let's do x bar minus 2s. That's a 3.51 minus 2 multiplied by 1.29, and this gives us a 0.93, and x bar plus 2s will give us, just use a calculator, it's going to give us a 6.09. Okay, so what can we see from this? We can see that actually what we can do is that we can use the stem and leaf, right, to see the number of observations that are between 2.24 and 4.8, right? So first let's go to the stem and leaf and see how many values lie. Then we can find the percentage. Okay, so use the stem and leaf and see the number of data points in this interval. Then I'll be able to find the percentage. Okay, so 2.2 and 4.8, let's go. Stem and leaf. 2.2, from 2.2 till 4.8. 8. Okay, so 2.2 onwards. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. So 29 observations lie in this interval. So what is the percentage? If 29 observations lie between 2.22 and 4.8, then the percentage, okay, so we were interested in the percentage, is 29 divided by 40 is a 0.725. So the 72.5% of the observations lie within one standard deviation away from the mean. So this shaded region that I did initially from the pencil, this shaded region is a 72.5%. Okay, let's see the number of entries in this range. So from 0.93 to 6.09. Okay, 0.93 means from 1, and 6, actually all of these entries are come in the in this, besides one entry which is an 8.2. So 39 actually entries. This was easy to see. So 39 observations lie in this interval. So the percentage, we expected the percentage to be more, and as you can see, it is more. It is 97.5%. So the area that is shaded in yellow is basically 97.5%. So I think that was the end. That was the last question. I hope this lesson was useful. The next chapter given in the study guides is chapter 3, which is on probabilities. So I'll be solving questions on probability next. I hope this lecture helped you, and I'll see you in the next one. Take care.